Hi there, my name is Samantha, and this is my psychology project. So I decided to go with a 2D version of the brain, and as you can see with the little details and whatnot, I decided to go a little bit more creative and artistic with my diagram, I guess you could call it, of the brain. Assuming that you've seen the brain in a lot of realistic pictures and drawings, especially from other students that have contributed to this project. So I guess I just wanted to show you the brain in a different perspective or a different light. Also, you may notice that the colors may be a little hard to differentiate, which I will account for that throughout the video. So yeah, let's get started. This bright pink color is representative of the frontal lobe. The frontal lobe is at the front of the brain, hence the name, and it accounts for your decision-making skills, planning for the future, attention span, and inhibition. The frontal lobe also accounts for motor functions, problem-solving, spontaneity, language, initiation, judgment, impulse control, and one's social and sexual behavior. It also contains most of the dopamine-sensitive neurons within the cerebral cortex. The dopamine system is associated with some of the things that the frontal lobe controls, such as attention, reward, short-term memory tasks, planning, and motivation. Now this dark red color, that is the temporal lobe. Located behind the ears, the temporal lobe is involved in vision, memory, sensory input, language, emotion, comprehension, and your hearing. The fact that the temporal lobe plays such a large role in things such as our vision and hearing allows us to process faces and scenes, which in turn helps us to classify them into meaningful information that can be used. With memory, the temporal lobe plays a major role in short-term memory, long-term memory, and spatial navigation. But to be more clear, many doctors focus on this part of the brain when their patient has a disease like Alzheimer's, one that hinders memory. In the middle of the hemispheres is the occipital lobe in a bright blue color. The occipital lobe accounts for the main visual processing center within our brains. Being the primary visual cortex, our retinas receive signals and then transforms them into images that our brain can understand and store away for future use at any time. Now, with all that said, what it means is that without this part of our brain, it's possible that we wouldn't be able to recognize people, everyday objects, our locations, or things of the like. Though some do have the ability to hear the quote, "What the eyes see and the ears hear, the mind believes," isn't entirely untrue. Now, if damaged, the occipital lobe would allow us to see things in a blurred fashion. For example, many people who get concussions have hurt their occipital lobe, and they may experience blurred or distorted vision. Now, the dark blue color here, split between these two pieces, which I will explain later, is the parietal lobe. The parietal lobe affects our recognition and ability to manipulate objects and the feeling of touch. By that, I mean that the parietal lobe interprets pain, pleasure, and pressure. Along with that, the parietal lobe is also responsible for perception and language processing. That means that the parietal lobe helps people to recall words when others are speaking, but the work of this lobe is entirely involuntary and unconscious. Now back to these two pieces of the brain that split the parietal lobe in half. The front part, so the green here, is called the motor cortex, and the one closer to the back is called the somatosensory cortex, colored in orange. The motor cortex is essential for motor function, and it generates neural impulses that control the execution of movement. The somatosensory cortex receives all sensory input from the body, such as the feelings in our skin, pain, visual, and even auditory stimuli.